So I'm going to talk about kind of my experiences engaging with the cloud, and which is kind of a mess in a lot of ways, and kind of what's come out of that, and hopefully give you some real examples that makes it easier for you to understand what that mess is like and make it not as much of a mess for you, and how you can kind of get in there and really get some stuff done. So I'm Wesley Beary. I go by Gmus online. That's what you'll see on Twitter, GitHub, stuff like that, or IRC. That's where you can find me on the web, basically, is just my GitHub account. That's probably the main point of contact. You can kind of see what I'm hacking on. Fog's obviously a large part of my focus, but there's a lot of little things that I do here and there. And Gmus on Twitter. I work at Engine Yard. I have the good fortune of being paid to work full-time on my own open source project, which is fantastic. If you ever get that opportunity, I really recommend it, but I don't really know how I did it, so that's kind of how that works out, I think. And it's at engineer.com. Their Twitter is Engine Yard. I think probably a lot of people in this room have had some exposure to that. It's a Ruby hosting platform that's built. Well, we have a couple offerings now. One's kind of on top of Amazon, and one's on top of Terramark. Kind of a more entry level versus a more advanced offering. And they both use a lot of fog underneath the covers, which kind of maybe helps explain to some extent why it makes sense for them to have me around, so that expertise is in-house. And the next thing, I think it's important to just take a moment and say, all right, when he says cloud, what does he mean? I mean, do I mean in the same sense of the, to the cloud Microsoft ads, or, every single marketing thing that's related to computing at all that seems to have the word cloud in it these days? No, I really don't. For me, cloud is API-driven on-demand services, right? Like, this isn't every single thing that the word cloud is applied to these days. And I mean, cloud's kind of this nebulous thing. You could use it on all these things, but for me, it's not. When I talk about cloud and what Fog is interested in, it's this, right? And I think some of the core things, the things that I've already done some work towards, are compute service, DNS service, and storage. There are other ones, obviously, that may get added to that. That's kind of right at the middle right now. I think like key value stores, like hosted key value stores are interested, hosted load balancers, hosted queues, stuff like this. But those are kind of like, there's not really a lot of offerings. And to some extent with Fog, like if there aren't 3 people in the market offering it, it's not interesting yet. Like, yeah, it's great that, Amazon has a queue, but unless there's 3 queues that I can look at and really evaluate and figure out what consumers of queues want, it's very hard to make a good abstraction on top of that. So kind of diving into that, what is this cloud thing? So it's on demand. It's important because you only pay for what you're actually using. It isn't this world where you say, I'm going to need 10 servers next month, so I'm going to pay for a month of 10 servers. It's, I need 10 servers for the next hour, so I'm going to pay for an hour worth of 10 servers. And sorry if this is a little bit rudimentary. I just want to make sure, like foundation, same page. It's flexible. You can add and remove stuff in seconds or minutes instead of maybe weeks or months, as it might have taken if you had to fill out, these are my requirements. I'm going to need this many servers and have to get who knows how many people to sign off on it. So it's very fast. It's this, agile almost infrastructure. It's repeatable. I think it's really important that, it's not that you got a box from Dell and it happened to work this time, so you could get another box from Dell and it would work again. It's that you can actually run this code, test what you're doing with your infrastructure, make sure that it works, shut it all down, and you should be able to do it again, and it should work exactly the same way. And there's also some resiliency there, and this is kind of a mixed bag, right? Like, there's a possibility that these resources might disappear. It's maybe not the most likely, but by coming into it with that mindset, you're more likely to work around that problem and actually have an infrastructure that can deal with the fact that a server might go away, because it's really something that we should all live with on a day-to-day basis, regardless of whether or not we're in the cloud. But I think we are, it's easy to forget about that if you own the hardware, because if anything went wrong with it, you could go fix it. So maybe you don't need to worry about something going wrong with it per se. So hopefully that's kind of healthy. So you might say, oh, yeah, that's great. This is all great, but where do I even start? What provider should I use? Who's better? Why are they better? It's intimidating. Every single service has its own area of expertise that, all of a sudden there's all this stuff that you need to know in order to be effective. And then, you get to looking at the tools to try to figure out if there are tools that will make this easier for you. It seems like every tool has a little bit different interface than the last one. Some of the tools are very high quality. Some maybe haven't had a patch in a year and a half. Like, did anything important on that service happen in a year and a half? Maybe, maybe not. Some of the services are very slow to change. Like there's so many things that's very difficult to figure out where to even start. This is where I came into this about a year and a half or 2 years ago when I got started on this project. So my response to all of this was to start, maybe very naively, maybe egotistically, maybe masochistically, I don't know, start on this library that was trying to accommodate for some of these things. So I call it Fog, and it's a Ruby Cloud Services library. So that's where you can find it. There's also a Twitter account. So if you have specific questions or something, you can kind of hop in there and ask them quickly, or there's an IRC channel. There's other ways that you can get more information. I'll go into that a little bit later. And so why did I write another cloud services library? I mean, there are other ones out there. The first off is that I very specifically try to work towards it being portable. Here's just a handful of the providers that have services implemented in Fog. And it varies. Some have very complete implementations. Some have somewhat less complete implementations. But there's a lot of stuff in there. It's also very powerful. There's a lot of nice abstractions that actually make it a lot easier to work with it. You don't need to know that it's describe instances, but it's list servers on a different service. Like that doesn't really matter. You can work with it kind of on your terms instead of on their terms. And it's established. We just recently hit 50,000 downloads of the gem. There's 860 followers about now. There's a little bit more than 100 forks. There's 40 contributors. As I said, I work full time on it. That's more than a lot of the cloud tools can really say. So I mean, like it's here to stay. It's growing. It's getting better every day. And another thing that I think is really valuable that not a lot of the other tools necessarily have is there's actually some built-in mocking in a lot of places, so you can actually simulate what would happen in the cloud without actually having to pay the cost of those resources. And especially one of the hidden costs, I think, is if you're developing this stuff, there's a high cost to the amount of time it takes to actually provision resources in some cases. I mean, if you have to run a bunch of tests that involve spinning up a bunch of resources and it takes 5 or 10 minutes to even let the resources spin up, let alone run tests on them, and you want the test to be isolated, so you don't want to use the same resources for every single test. By the time your before and after each blocks have started up and shut down a server, each test takes 10 minutes or something. I mean, it's just not it's not really feasible. So in our work at Engine Yard as well, we use a lot of mocked out stuff, and that comes from that we can run a lot of these tests and have a high level of confidence that we're doing the right thing without waiting 6 hours to find out we're doing the right thing. And so another thing is like who's already using this, and we already have some big users. Gemcutter actually uses it, which is what powers Ruby gems. They use it for their S3 interactions. Engine Yard uses it for our platform. I mean, like we already have some pretty big users out of the gate. I don't think you need to worry too much that it's not stable or that it isn't, going to be around. There's enough interest that I think we're past that point. And so that's great, but probably the most frequent thing I hear is, I don't know how I would use that. That sounds great. Yeah, that's great, but I'm never going to use that. That doesn't apply to me. All right. So I'm going to try to fabricate a use case for you so that you can get a better idea of how this might fit together. All right. So we're going to be entrepreneurs and we're going to write our own web service. Right. And so I've decided that this up service is going to be about uptime, because who wants a busted website, right? That's going to be our tagline. We have this business lined up. We're going to make an uptime monitoring service, right? And this is good because the location of the things matters, right? And we have access to a bunch of different clouds. We can spin up boxes wherever we need to. We can do this pinging. We can aggregate data, et cetera, et cetera. So I'm going to walk through what this might look like. There's some code coming now, just in case, prepare yourselves. So first off, just to get set up, either sudo or not, gem install fog, kind of depending on your setup. I usually try to use RVM, so sudo isn't necessary, but if you're just using default stuff, you probably need to use sudo. And the first thing is you just need to get a connection to the service that you care about, right? So this is going to look something like this. You're going to say, I want a compute thing from Fog, and I want it to boot based on some set of credentials, right? So here's an example set. This is for Rackspace. I'm saying it's the provider is Rackspace, and I'm just using some constants so that you won't boot a bunch of instances and cost me money, because that's no fun. And the next thing is pretty simple. You have this compute thing. That's your connection to Rackspace, and it has a notion of servers, which is a collection. So you kind of get into something akin to data mapper or active record isms per se here. Servers is a collection. It has a bootstrap method. So I'm going to call that with something called server attributes, which looks like this. It has an image ID and a place where it can find private and public SSH keys for me. And so you might ask yourself, what is this servers thing? So first off, if you just call compute.servers, it gives you back a list of them. This is the same as calling compute.servers.all. It's like a lazy array, so it'll fill itself in if it needs to. You can call servers.get with an ID. This is a totally junk ID. This wouldn't really probably give you anything on Rackspace but an error. But nonetheless, that'll give you back a particular server. You can call reload. So the value of this is there are certain cases where maybe it basically caches the data. So if you pulled back a list of servers, but now you're here 10 minutes later and you know that the guy sitting next to you at your desk has the same credentials and he's testing something too, you might want to call reload to make sure that he didn't create 10 new servers that are going to conflict with what you're trying to do when you call servers array index 3 or something, because that's what you expected your server was going to be. You can also call new. What this ends up doing is, this is kind of, again, an active record type ism. You end up with a local model that represents what a server would be without actually spinning it up on the remote service. This can be useful sometimes to kind of like stage your changes, kind of stage all of your attributes that you're going to use, and then you can call save on it to actually say, okay, now I really need you to go do your thing. And then there's create, which actually is just that new plus save kind of thing that I said before. So then, of course, I left out Bootstrap. What in the world is this Bootstrap thing? I'm cheating, right? So Bootstrap is actually, it's a convenience method that is specifically for servers, because servers isn't the only collection. It just is the one that you care about when you're making this site uptime thing. So this actually bundles together a few things specifically for servers. It's going to call create with the attributes you passed in. And then there's a method called waitFor, which takes a block, and the block gets called inside of the server, basically. So there's this ready method that checks and says, am I running yet? And this is handy because on every service, lo and behold, every single service has a different way of indicating ready, right? Like it might be state, it might be status, it might be ready, it might be running. But you don't have to worry about it. You just say ready, yes, ready, okay. So this will loop until that returns true, or 10 minutes pass and it'll raise an error, whichever comes first. And then there's an SSH method. This is why we pass those SSH keys in the first place, is that as part of the Bootstrap, it actually will take the key that you gave it and make sure in some way, shape, or form it gets placed on the server. And that varies a little bit from service to service. Some will let you provide it up front and they'll inject it for you. Some you need to take a root password that they gave you and log into the box and place it and then disable root password so that somebody else can't maliciously take the root password that the service is kind enough to email to you in plain text. So there's a lot of things where, this kind of like smooths that over. You don't need to know what all these different services are doing. Fog takes care of it. So now we actually need to get this data to see if our site is up, see what kind of response times we're getting. So we can use this SSH method now that the keys are in place to actually call and send a command over the wire. So I'm going to call ping-c 10, which means it runs 10 pings, and then you can get some aggregate data back from it. And target in this case would be whatever site your customer has that you want to make sure is going, right? So from that, we can say, I just want the standard out. Hopefully it didn't error or anything. If it did, we could do more complicated stuff, but we're going to use best case to start with. And then you're going to parse the result, right? So the last line looks like that. It's a summary line. And then I do some crazy splits and stuff. I apologize if that is incomprehensible. Regexes would have been worse, I swear. And the thing that I think that's important to note here is this is the most complex slide of the entire thing, most complex code, and this is parsing a string from ping. It wasn't booting the server. It wasn't placing the SSH keys, nothing like that. All that stuff was super simple. The most complex thing you had to do was parse the output of the SSH command you ended up running. So then in terms of cleanup, you can call destroy on the thing, does the right thing, shuts it down for you, and then you can get the data back as a hash. That's the data that got parsed back out of that crazy string parsing stuff. And then we can move on to the next step, right? So the next step is, all right, that's great, but now I have ping from only one location. I want to make sure that even though the ping was good from US West 1 or whatever, which is somewhere in California, I want to make sure that the ping is good from, US West East or whatever, right? So in this case, instead of using Rackspace, we're saying it's a provider of AWS. Here's the keys, and then you get a little bit different server attributes. This is an area that I'm still trying to work on to make this less disparate. But as it turns out, Rackspace versus Amazon, they index images differently, right? Like they don't use ID of 47 as Ubuntu no matter what cloud you're on. Like there's some things that are going to be very hard to just work around. So you may have to go to a little bit of extra effort in that case. But I'm hoping it's a relatively small amount of effort compared to obviously what it would be if you had nothing to go from at all. So this would be an example of that. And then to further, that example, you could also just merge in a different credential for the region for Amazon so that this would add a few more places that you could ping from. You're up to maybe 5 or 6 now, and it's fairly distributed. Rackspace is in central time zone roughly, I think Austin and maybe Chicago or something. Amazon can give you left and right coasts respectively of the US as well as Asia and Europe. Like that's not bad in terms of your ping data. That's a pretty good distribution around the world. But even beyond that, there are all these other services that have a lot of the same functionality, work more or less the same way, and pretty soon you have all the data you could want. So you just kind of lather, rinse, repeat. It's the same thing. So that's awesome, but how did I know what image IDs I wanted and how these other things fit together and what methods I needed to call? Well, there's actually a fog binary that comes when you install the gem. You can just type fog. The first time you ever run it, it's going to look a lot like this. It's going to output a big chunk of stuff that's YAML, and it's going to say, if you set up a file that looks like this and ~/.fog, you're going to be happier because then it will boot and will actually have access to stuff. And so here's an example. I've set up some credentials. I have Amazon and Rackspace. And so the next thing that I'm going to talk about a little bit is what I'm going to call signposts. So there are ways that you can basically say, okay, what can I do now? What can I do now? I don't understand, like in this context, what can I do? So the first is just at the top level, you can select providers. This will give you back the same list that was kind of like nicely printed before. So oh, Amazon and Rackspace. So Rackspace, what collections are available? And so it has directories, files, flavors, images, and servers. Okay, so this is another thing that I can say, Rackspace compute. I just want the compute provider. I don't want this mixed list of all the collections. And it'll give me that. Or I can say, give me the requests. And it'll give me a list of the lower level things that are happening behind the scenes of the collections and models that are usually hidden away from you, but every once in a while, maybe that has something that the abstraction is not providing. And so those particular requests, just to, as an aside, kind of to let you know what that looks like, because every once in a while you need it. It gives you back an XCon response. XCon is the HTTP client I'm using, which has a body, headers, and status. Pretty straightforward if you know HTTP stuff. And the downside to this, of course, is the body will almost always be like just kind of a hash of something. It won't necessarily be parsed into a nice object. But if you know what you're doing, this can be great because you might need to do something that the abstraction does not provide, as I said. So then we're just going to go back and do a sanity check. We're going to check to see if we have any servers that are still in the ready state. I think part of that is gone. It's supposed to delete them afterward, I think. But anyway, you're making sure you don't still have any servers running because you don't want to pay for them. I've made that mistake more than once where I realized a day later that I still had 20 Amazon instances running and I was out $70 basically or something. So I would definitely recommend trying to do this anytime you play around just because otherwise badness. So now, how did I find the image? How did I know it was 47 or whatever was Ubuntu that I wanted? So if I call images, this is going to give me just the list. There's a table helper, so you can say, I want a table of the images that just has the ID and name. And you'll get back, I obviously omitted a large part of this table, but you'll get something back that looks kind of like this. It looks kind of like the MySQL table output that's in the console or whatever, which can make it a lot easier to look particular things up, and that works on any of the collections. And then for AWS images, I just cheat usually and there's a listing on elastic.com of kind of what the official Ubuntu releases are because the actual list you get back from Amazon of images is incomprehensibly large and dense, and it's very hard to figure out what you might actually want from it. And so it's great exploring, but it takes a long time, sometimes to spin up servers or whatever else, and it's expensive. And so I'm going to go into the mocking infrastructure a little bit so you can understand how you could also do this exploration that way instead of doing it against live for the same benefits that you get from running tests. So for this, you can either do fog mock equals true and then run the binary, which will just turn mocking on before it kind of boots up into the binary. Or after you've required fog, you can call fog.mock bang in order to turn that on. And it's a simulation, right? So what happens is most of the functions just work. it just keeps kind of an in-memory hash of these are the instances that this person has asked for, or these are the volumes that they've asked for, or whatever, so that if you make subsequent calls and say, give me my list of servers, it can tell you. This doesn't cover everything. I mean, it's pretty hard to make an in-memory simulation of what SSH would do on a random machine that's running Ubuntu or something. So there's a few places where it kind of punts, where it either just raises an error, or perhaps it just says, this is always going to work. I don't care what you run on SSH, it's going to return true, basically. There won't be errors, there'll be empty strings in standard out or whatever. Most cases, though, it won't just be that. It'll be either it'll work, or it's an unimplemented mock, so it'll raise an error that very explicitly says, sorry, this is an unimplemented mock. If you really want this behavior, maybe you should think about implementing it, because I haven't gotten around to it yet. So in that way, it should help keep you on track, and it can move things along in terms of making sure you're on the right track. And the other thing is that I run all of my test suite against both the mocked and unmocked stuff. So there's a few cases where I've just marked test pending if mock mode is on, because I literally haven't implemented the mocks yet. But for everything where the mocks are implemented, I would expect that all the tests pass. So if you run into a consistency issue where something in the mocks and something in real life don't actually agree, that's a bug. I'd appreciate it if you report it, and I'll try to get it fixed. The ideal is that they work exactly the same. I think that's probably incredibly unrealistic. So, I mean, they work as much the same as is reasonable and as is, helpful in terms of testing and simulation. So, back to business. All right, so we have all this data. Now what are we going to do with it, right? So now we're going to talk about using cloud storage so that we can actually aggregate some of this data. This probably looks a little bit familiar to you. There's a little bit of repetition coming into the presentation now. We use fog storage. We boot up this storage thing. Credentials look like that. Looks a lot like the AWS credentials from the compute thing. And then we have directories.create. Directories in this case are the container that have many files in them. And then we say this is the key that we want it to be called and whether or not we want it to be public. And then we say I'm going to create a file. So the body is at this path. If you use the file.open version of that, it will actually stream it for you, so you don't have to really worry about that. You can also just explicitly pass a string if you already have it in string format, or for some reason want to read it into a string, and it will also stream that string, but you don't really gain the same benefit of not having the whole thing in memory then. And then you can set the key and set whether or not that's public as well. And then you can use the public URL method to give you back a public URL if there is one. So whether if you've set it to private, this will actually just return nil. Or if you're using a service that doesn't have public URLs, for instance, there's a local store which you just say, I want you to put everything in the directory called foo, home/foo. And so that won't have a public URL because there's not really a direct way to serve that. So you'd get nil back. But that's across the different storage providers, which makes it pretty easy to use. So speaking of that, geostorage, this is probably reminiscent to you of stuff where part of my slide is missing. So you can use these same credentials to create a new connection to a Rackspace storage provider, and that exact same set of code will work exactly the same way. Well, really, it's completely different behind the scenes, but I mean, it's transparent to you that it isn't the same. And then again, kind of in terms of cleanup, you want to get the directory, iterate over the files in the directory and destroy them, because you can't destroy a directory that isn't empty, then destroy the directory. This is less important because this stuff's cheap, but it's not like the servers where you're going to really regret it. So, this back to geo aggregating, right? So AWS is done. There's Google Local and Rackspace. So you can lather, rinse, repeat, again, you might be getting the idea by now, I hope. So phase 3 is profit, right? We have our service, we have data, we're aggregating that data, but now we know that we need to make some money from it. So we've decided we're going to implement a freemium model because that's the thing to do to make money, right? So what we're going to do is offer premium access. So if you register your company, Foo Company, at my service, you'll get foocompany.myservice.com, right? You can send your customers there and they can see just how many nines you have, which is fantastic, obviously. More nines better. All right, so create a DNS connection. This, again, probably looks familiar. We're going to use Zerigo this time. It should say probably Zerigo access stuff instead of AWS. Mistaken my slides, I apologize. So we create a zone. You just pass the domain that you want and the email that you want. And then you're going to create a record. That's obviously a bogus IP address, but whatever the IP address of the server was, which you could get back from the servers that you created earlier or the server that you have running somewhere else, just kind of whatever. This is really handy because if you're booting and shutting down a lot of servers, this is a way that you can actually tie that into your DNS. You can use this, maybe you could use round robin DNS or something so that you'd have it distributed over the 10 servers that you happen to have running on Rackspace at a particular time or what have you. In this case, though, we're just going to add an A record that's going to be customer name.domain name. Pretty simple, but now there's, our magical subdomain. We'd have to do some stuff behind the scenes to do the right thing on our app probably, but by golly, our DNS record's there. So again, probably want to go through and clean up. It's just good practice. I just want to emphasize that because this stuff costs money, and I hate it when I cost people money that they don't want to actually spend. Like that's just, bad business. So this, again, there's 4 providers for DNS right now. We took care of Zerigo, but you can just repeat the same code and it'll work across these other providers. So just a moment to talk about what the roadmap looks like. I have a strong intention of working on compute. I could pretty easily say, as you saw from the slides, you can run the same code for DNS across all of these providers and the same code for storage across all these providers. And when you do it with compute, it's sort of almost the same except for these 10 exceptions, right? I want to make that like 9 exceptions or something instead of 10. So that's coming up basically is trying to smooth those edges. It's obviously like a bigger problem space. There's more providers. The providers do it in much more disparate ways. Like it's a lot harder, which is why I haven't really done it yet. And I keep basically procrastinating by working on the easy stuff, but it's slowly getting better. Another thing is just kind of working on completion. I think in the near future, I'm probably going to pick a sort of core set of services and say, these are the big boys. These are going to get everything. I'm going to make sure they have all the requests and models and that everything's mocked and everything's tested and so on and so forth. I don't know what that set is yet. I'd love to hear feedback of what people are using Fog for, what they want to make sure gets into that core set. Amazon is probably a gimme just because we use it at Engine Yard, and it's also probably one of the most used services in there, but some of the other ones are probably more on the fence. I'm not going to throw anything out completely, but there's just some stuff that I won't necessarily throw as much time at. So, that's going to depend on what people need. And errors is a big thing because obviously every service returns errors a little bit differently. I've done a little bit to try to smooth that over so that you'll get similar errors from different services when similar things happen. But it's also a pretty difficult thing, and it's not always easy to necessarily cause those errors when you want them in order to make sure that everything's working the right way. So that's an area of focus. And of course, documentation is always a big area of focus. I'm trying to work more on, there's been a few blog posts recently, but adding more of those, adding more examples. I have an examples directory in the Fog project now that has sort of best practices for DNS and storage that will actually walk you through kind of the workflow that I was mentioning of like, if you're willing to, if you're willing to accept a certain sort of subset of the total functionality of these providers, they are pretty interchangeable, especially for DNS and storage. So those walk through what that kind of best practice looks like. And then you can kind of go off the path once you pick the one that you really want to use if you need to. And also there's a website, fog.io, which has practically nothing on it yet, but it exists, and I'm trying to kind of flesh that out. But I want to open up to questions. I know that's a lot of information in a very brief period of time. So the question was basically, what is the relationship between Fog and something like Chef or Knife, right? Knife is a tool that actually kind of sits in between. It's a command line tool. It uses Chef to configure machines. It has Fog integration actually for a number of services already, so that you can say like Knife, AWS servers create or something like that, and have a config file somewhere, I think, that says the attributes like that, kind of like I was passing in. And so it's this weird kind of thing. Like, I honestly feel like Knife is very strange, right? Because part of the goals and, what the plan for Chef is that it's repeatable, that you can check it into source control, that, you have this very defined set of things. And to me, a command line tool is the exact opposite of that. Like a command line tool, you can't check in the commands that you're running on the command line tool, not in a meaningful way really anyway. It's hard to repeat because it's easy to forget exactly what invocation you used. So on some level, I can't help but feel like Knife is a really cool like demonstration conference application kind of thing. Like, it's a very cool way for the Chef guys to quickly show what it can do, but I feel like it's maybe not what you want at the end of the day. And so The other thing too is Fog itself doesn't really try to be very opinionated or go very far in terms of configuration. Like I showed you guys very briefly the bootstrap, which will place SSH keys, and there's the SSH command, which you can pass basically arrays of strings into, and it'll run this array of strings as a bunch of SSH commands. Yeah, technically you could write scripts that use that to configure the server and do everything you want, like you could just run this huge thing, and you could check into source control this huge list of commands, but that's also not really repeatable, not very easy to parse what's changed or what's different. So I think there's space for both, but there's space for both Fog and Chef. I don't know about Knife. I feel like Knife is a cool toy. I know that a lot of people don't use it that way. Like a lot of people use it as like the thing that they use. I think the thing is that it's still kind of this mindset of like, well, we kind of are used to controlling the hardware, so we don't really like we'll act like we control and own the hardware regardless, right? Like you use Knife as though you were going to walk out and put a machine into a rack, right? It's not really like I'm going to use a tool that I can run over and over again because this might fall over, right? Like, and I think that that's unrealistic, right? I think all of that being said, that there isn't necessarily a good tool that integrates the two. Like I actually am interested in trying to figure out at some point somehow maybe what that might look like. I don't know if that's creating some kind of DSL or something that kind of better describes like this mapping from nothing into servers plus configuration. Because I know that Knife tries to do it, but I just feel like Knife tries to do it in a weird way. And I don't know, like in a way that's opposite of what they're trying to promote. I don't know, maybe that's just me, but the question was about, so with that being said, like kind of in the current state of things, how you actually go from a server that you've spun up with Fog into actually running Chef. So the first thing I would say is if you're curious about that, one place that you can go, because it is there, is if you open up the source code for Chef in the Knife tool, it's already doing that. So I mean, like if you're just curious, like how in the world might you do this? Like they already are doing it. Like there's a pretty good example there. Like I said, the way that you actually invoke it, I don't necessarily like, but I mean like the code does the right thing. So if you pull that up, you can see how they're doing it with a few services anyway. I don't know if you would say that they're cheating per se. Part of it that makes it very easy is in most cases, the image that you actually boot up is an image that they've kind of pre-prepared. So the image will already have, Chef and Ruby, and like it basically has everything on it already. So you just like start it up and download the config stuff that you need in the recipes, and then you run them and you're kind of done. If you're starting with just like a raw Ubuntu image or something, it's more challenging because presumably it doesn't necessarily have Ruby. It doesn't necessarily have, it might not even have GCC, right? Like there could be a lot of things that might be missing, and you might have to walk down that list of things and get them installed and perhaps store that off as an image so that you have this base thing. That's always a battle too. Like how much do you put into your configuration rerunnable stuff and how much do you actually bake into the image itself? Image is obviously less flexible, but considerably faster generally. Like, oh, I'll just boot this image up that has everything on it. I'm done. Versus, yeah, but what happens when in a year when you're still running that machine and you can't really just turn it off, but you want to have the latest and greatest? Like obviously the configuration can pull it up to latest and greatest. You can't necessarily shut it down and just spin up a new one. Also perhaps old mindset. Maybe we should just make everything like we can spin it down and bring it back up, and images are the way to go. I don't know, because image maintenance is a pain too. So, but yeah, I would say Knife tool has good examples. But basically that's what you end up doing is you end up SSHing into this box, placing keys. In the case of Knife, they aren't actually using the bootstrap stuff that I showed. I added that after they had written the Knife stuff, as I frequently do, of like, oh, somebody's doing something really cool. I can see how that would be useful to my entire user base. I'm going to, kind of beg, borrow, and steal to pull some of that stuff back in. And then it sometimes takes a while or never to then, have the cycle return to them using the stuff that they inspired in the first place. Okay, the question was for people that are a little bit newer to this, since I kind of like dived right in, like where would you maybe go to get started? Kind of like a 5-minute introduction to this stuff. There are a couple things that are helpful. Like I said, there's the examples directory that's in the repo itself. I think that's pretty good. It walks through some stuff, especially for DNS and storage, that kind of walk along all of the things that you might want to do, listing things and creating things and that kind of stuff. Also in this list here, this examples thing right here, this gist, this actually has a little bit more elongated versions of the code that I had in my slides. So it isn't just like kind of all chopped up and you see like 2 lines on each slide. Like it's actually like, here's the example of the aggregator. It does everything in one file and it has a lot of comments and stuff. So hopefully if you found that example interesting, or, you know, it's just something that hopefully you can relate to. I was trying to get an example you could relate to anyway. It'll walk through a lot of that stuff and hopefully that helps. So the question was, and hopefully like all the huge QA section of this isn't too boring for you guys. I didn't really expect to get through the slides quite that fast. Ostensibly, I guess it depends what you mean by competitors, right? There's definitely like, for instance, for S3, right? Fog is obviously not the only library that does S3. There's AWS S3 and there's Write AWS, and there's only 2 that come to mind right off the top of my head, but I'm sure there are more. So first off, on some level, it's very hard to say that those are necessarily competitors with Fog per se, because Fog isn't just trying to be an S3 library. And to some extent, by using Fog for your S3 library, there's a lot of benefit that you gain that isn't having an S3 library in Ruby. I mean, like the flexibility to be able to meaningfully say that you could move to Rackspace storage instead if you needed to, because you were getting better prices or better latency, or you were moving your compute stuff to Rackspace or what have you. I mean, that in and of itself is a huge value. The mocks, I think, can be a huge value in a lot of cases, and a lot of them don't provide that. And the other thing too is, in some cases, which was something that I had noticed even when I was starting on this project, some of those projects aren't very well maintained. I think in a lot of cases, a new exciting service will come out, S3, whatever, and people will come into the space and write a gem over a weekend and never look at it again. I know that's like, for instance, AWS S3 is in very common usage still, and I think the last patch to it was 2009, April maybe, if I remember right, April 10th or something. I don't know, like a really long time ago. There's a bunch of features that have been added to S3 since then. Most people probably don't care about those features, but they are there. I mean, and if a bug does come up, I mean, if the last patch was then, do you really think he's necessarily going to someone will come magically out of thin air and fix this bug when nobody's touched it in a year and a half, 2 years? So, I mean, that's another benefit. It's just that unlike a lot of his other projects, this is very actively developed. Bugs usually get fixed very quickly unless I report them, and then I'm lazy about fixing my own bugs. Because if somebody else hasn't complained, it might bug me, but I'm too much of a perfectionist to not be bugged by something at any given time. So the question was kind of about credential management. It can be a little bit tricky if you get to the point of having multiple keys, especially for the same service. Most of the way that stuff is set up in Fog, it kind of assumes that you're just using one set of keys for a given set of operations. I mean, the way that you would interact with it, I guess, is how you did the like fog compute.new. Each time that you call that, it creates basically like a new separate socket or whatever. So you could call it a bunch of different times with different credentials and get different connections that would all be to different stuff. I'm not sure that was really your question per se. In terms of actually managing the credentials, there's not a lot per se other than the sort of ~/.fog thing. It's kind of like a database.yaml file, if you're familiar with that from like Rails or something. So you can create these YAML files that have basically like, here's maybe my like development credentials and here's my production credentials. And when you go into Fog, you can say fog.credentials equals and give the path to that, and then fog.credential equals, say, development, right? And you could switch that based on your environment or whatever, and that can be one way that you could do that, or by setting, other environment variables or other things based on which developer was running things, so you could all have your own credentials. Like the main way to do it would probably be based on that. Just use that switch and use those files so that each person can kind of maintain their own state. So the first question was kind of a question of, in one hand you have standards, and in the other hand you have Fog. How do these stack up against each other? It seems that in a lot of ways standards aren't really winning, so how is Fog going to win? I think that's more or less accurate. It's difficult. One way, well, I don't know. I mean, I have corporate sponsorship now, so that kind of messes with that. Previous to corporate sponsorship anyway, I have a mixed faith, I guess, at best in standards frequently, because there's so much money involved basically that like there are so many people generally butting heads about what that standard should be, that frequently it seems to involve business needs and desires more than it necessarily reflects what the actual technological needs are. Which, I mean, so like for instance with OpenStack, right? It came out originally with, I think, pretty much an AWS compliant API, because, you know, that's kind of what the standard was in some sense, the standard, and the same way that Eucalyptus has an AWS compliant one. You know, everybody knows it, and it's very common. And now all of a sudden it appears that they're going to deprecate that and it will be a Rackspace API instead. I mean, that seems really political. I mean, OpenStack's supposed to be a standard, and it's being defined by who happens to be throwing the most money away. I mean, that's very cynical probably, but I mean, I think that there's always that danger in standards, is that the standards bodies are usually have like people from big companies sitting on them, and they're funded basically by these big companies. And so it's difficult. And also in that case, there's NASA on one side and there's Rackspace on the other. I think they have very different needs for what that cloud's going to end up looking like, which also like is pulling in two different directions. Like, I don't know. I just don't know that I have the most faith in that process. I mean, there are cases where it works out great, like, well, great, HTTP or something, right? Like that's a spec that, but I mean, nobody really follows it. I mean, that's the other problem. You end up with a standard. vCloud's another example. vCloud's a standard that VMware came out with. Few people ostensibly follow it. I don't know if anybody really follows it. Like everybody kind of has their variation, their own flavor of vCloud. So at the end of the day, I don't know that you gain that much. Like it seems like at the end of the day, if you're actually going to try to move back and forth between providers that have the supposedly same API, you're still going to have to code around the differences regardless. So if you're going to have to code around all the differences anyway, like why even bother to some extent? But also, I mean, like at the end of the day, as a developer, what have you gained? Like that's the other thing, is I feel like this sort of like more like grassroots approach almost gives us something that helps us now, and it's something that we can actually take action on. Whereas with standards, like when was the last time you interacted with a standards body? I haven't really ever interacted with a standards body. I don't feel like I'm like pushing those standards anyway that's going to help me. I don't feel like they seem to be pushing themselves in ways that are going to help me. I mean, so the question is kind of what are the kinds of things that are basically hard to simulate, I think, with FogMock? Like where does that fall short? There are a couple places probably. Like I said, one of the places is just like a very obvious thing that you're going to need to do is get onto machines and run commands. And that's one of the hardest possible things you could think to emulate. One path that I'd like to explore more that I haven't gone very far down yet is doing stuff with VMs actually for that purpose. That's not really mocking per se, but I mean like in terms of it being cloud versus not cloud, it's effectively like an in-memory local simulation of what would happen. That's probably a bit over the horizon to say the least. Like I don't know that, like I don't really unfortunately have the tooling that like, oh, I'll just require this gem and now I can spin up VMs and like, you know, like that would be spectacular, but it's not really at that point yet. So maybe in terms of that's one big thing. Performance kind of can be another thing. Like for instance, right now the S3 stuff works basically immediately. You say like create a file and it's there. And any of you who have worked with Amazon Web Services a little bit more than that probably will realize that it has this notion of eventual consistency. You do something and eventually it will be true, but it's not necessarily immediately. And there are some cases where that'll really bite you. So if you are relying on the fact that everything is immediately consistent, basically, because that's what the mocks happen to do, it's likely to come back and bite you. And in the case of a lot of the compute providers, I've actually purposely built in some delays into the simulation in order to emulate that on a very small scale. So you might boot a server and it might take a second or two to come up, which is still pretty unrealistic. But if you're doing anything that's like totally bogus, it'll probably call you on it. Like that's the idea anyway. And you can turn that off if it's just like too slow for you, or like maybe turn it on the runs that you do right before you deploy, but not have it on every single test run or that kind of thing. So hopefully that answers that more or less anyway. The question relates to, in some ways at least, to the VM question is of, does Fog provide stuff for doing more like private cloud kind of stuff, like internal infrastructure? And then does it therefore provide sort of a migration path from internal infrastructure or internal private cloud to public cloud, or having a hybrid? Not really, not currently. Engineered actually doesn't have their own hardware anymore. We are out of the hardware business where we just use other people's hardware now. So we personally aren't doing that. I know there's a lot of interest in that space. Similar to running hypervisors, people would like to be able to run cloud controllers, basically, whether that be, OpenNebula or vSphere or whatever, And so I'm open to the idea. I can definitely see how it fits in and how it would be very helpful for a certain class of users, but I haven't had enough interest, nor do I have a vSphere over here and an OpenNebula over here that I can test against. That's one of the problems that I've run into a couple cases of. I'd love to work on this thing, but unless I have a test set up, I can't have very much confidence that it actually does the right thing, regardless of what code might get contributed or what code I might write. So it's definitely something I'm interested in pursuing more, but I haven't quite figured out how to make that happen. I don't know if that's going to be sponsorship from someone or something of that nature or what, but I think there's definitely some interesting stuff that can happen, both in terms of being able to control local VMs and then move those VMs to the cloud, but also controlling a local cloud and a remote cloud and having more sort of uniformity in the way that you interact with those things. Thank you, everyone.